Okay, so we're learning to solve proportional reasoning problems involving constant rates. So a lot of the questions will say, at this rate, if the rate continues, how many kilometers will there be? Or if the rate continues, how much will it cost? Okay, so constant rate just means that you can still use proportional reasoning to solve the problem. Okay? And we're learning to use proportional reasoning to solve problems that also involve different rates. So this is going to be comparing questions. Okay? Who makes more money? This guy works at this rate, this guy works at this rate. If they both work for 40 hours, he makes more. By how much? Those kind of questions. Okay, so we're going to compare different rates, but we're still going to use proportional reasoning. Okay, so a rate is a comparison of two quantities. Oops. A rate is a comparison of two quantities that have different units. Okay, so rates you could see, I don't know, on Amazon or whatever, $2.20 per 100 grams, $4.95 for 500 sheets of paper, 300 kilometers in 4 hours, 1,300 meters per minute. Many proportional reasoning questions use wording such as at this rate. This means that the rate stays the same, just can be written differently using an equivalent or an equal sign. And equivalent ratio or equivalent fraction. So here's our first example. It's pretty straightforward. It would seem just like what we just did. Ken drives 180 kilometers in 3 hours. So we're comparing kilometers and hours at this rate. So if he continues on at the same rate, how long will it take him to drive 204 kilometers? Okay, so on the side, we're going to show that we're comparing kilometers and hours. And it tells us 180 kilometers takes 3 hours. So that's going to build the left side of our proportion. Okay, 180 kilometers takes 3 hours. At this rate equals, this rate continues, how long will it take him to drive 204 kilometers? So this is kilometers, it goes on top, and X, the number of hours, would go on the bottom. The hardest part of the question, get that proportion mean. Solving it, that is easier because we spent yesterday learning how to solve them. Okay? So we're going to cross 180x equals 3 times 204, which is 612. Divide by 180 on both sides to get x by itself. So there's our algebra in there. And we show our algebraic reasoning. So now we have to convert our answer to an answer to the question. So then we always include part of the question in our answer. At this rate, how long will it take him to drive 204 kilometers? So therefore, it will take him 3.4 hours. This time is measured in hours. Okay, so you've got your proportion, and then to get 180x equals 12, you're using proportional reasoning. Then you're using algebra when you divide by 180. Get your answer, and then your therefore statement. Okay? All right, the next example. I'm going to let you guys try it. So I had either pay over hours or dollars over hours for most people. Some people had money over hours. Either way, you're right. And then to set up your proportion, $75 per 4 hours. So those two go together on the left side of your proportion. Okay? At this rate, so equals, how much will Carl make if he works for 25 hours? Hours is on the bottom, so the 25 goes down here, and X goes on the top. Okay? That should be your proportion, or at least you should have X and 75 on the same level and 25 on 4 on the same level if you did it the other way. All right, so now you're going to cross. Always cross do your X first, so it ends up on the left. 4 times X is 4X. 75 times 25 is 1,875. I got to record again. No, I didn't. Oh, good. And divide by 4. There's your algebraic stuff. 468.75. So then let's consider what the question asks. How much will Carl make? So it's money, and money does have 2 decimal places, so I'm good to keep them. Okay, so then I just need my therefore. Carl makes $468.75. Okay, and you can make it even better if you add in 25 hours. You don't have to. Okay. Okay, Jenny drives to her grandma's house and back again. The distance from Jenny's house to her grandma's house is 120 kilometers. Did I miss one or am I good? Jenny's car uses 4.8 liters of gas for every 100 kilometers. Gas costs $1.02 per liter. How much money would it cost for Jenny to drive to her grandma's house and back again? So the issue with this question, and whenever this happens, it looks like we're comparing 3 things: kilometers, liters, and money. Do you see that? There's 3 different things there. So when that happens, you want to do 2 at a time. Okay? So first, let's leave this one for now. Leave this out of the question. And if we know that it's 4.8 liters of gas for every 100 kilometers, we can figure out how much gas she needs to get to her grandma's and back. Okay, so we're going to start off, ignore this one, and we're going to compare liters and kilometers. Because this statement here compares liters and kilometers for us. Okay? So we know that her car uses 4.8 liters of gas for every 100 kilometers. Now she's going to her grandma's house and back again. So how many kilometers is she driving? 240. So you have to do 120 times 2 because she's going there and back. So that means the number of kilometers she's driving is 240, and you want to know how many liters of gas she's going to use. Okay? So there's our first proportion. We're going to ignore money for now, and we're just going to look at liters and kilometers. Okay? So there's our first step. And if you're doing this question, if it's an EQAO question and you've got lots of steps, you might want to write, here's my first step. Okay, the first thing I'm going to do is worry about liters and kilometers. So I'm going to cross with my x first, so 100x equals 4.8 times 240. And then I end up getting x is 11.52. And it's good to write out what that 11.52 represents. Okay? Everybody good? So what does that 11.52 represent? The number of liters of gas she needs to go to her grandma's house. Okay, so therefore, Jenny needs 11.52 liters of gas. So there's the first part of my question. Now I know how much gas she needs. The second part of my question is going to be to see how much it costs for 11.52 liters of gas. There's two ways you could do this question. If you know she needs 11.52 liters of gas, but gas costs $1.02 per liter, how could you really quickly figure out how much it costs? Anyone? If you need 11.52 liters of gas and you know it costs $1.02 for each liter, what operation could you do between those numbers to figure out how much it costs? Right? You won't do that method then. Okay, we'll do proportion again. So we've got, we're comparing dollars and liters. So you're going to say dollars and liters. And be careful with this one, because that $1.02, it says per liter, that really means 1 liter, per 1 liter. So there's a 1 in the bottom here. $1.02 for 1 liter. We just figured out we need 11.52 liters. And then we want to know how much money that costs. That's going to be our X. So it's $1.02 for 1 liter. That's what $1.02 per liter means for 1 liter. So then, look what ends up happening here. Maybe that will help you see what the other way would have been. So find our X and multiply. X times 1 is X. $1.02 times 11.52 gives me 12.096. So all I did was take 11.52 liters and multiply by $1.02 for every liter. Okay, so I could have just multiplied, yep. Oh yeah, I multiplied by 1.05, I see it. And 11.52, 11.75, awesome. It's a nicer price anyways. 11.7504, but it is a money, so that means we're going to do therefore it costs dollar symbol 11, the 0 tells you to leave the 5 alone, $11.75 to drive to grandma's and back. proportions. First we compared the meters and kilometers, then we compared the dollars and the liters. So if there's 3 things in your question being compared, then it's going to require 2 proportions. Okay? So this is an EQAO question. The most common error of the year it was on was people just use 120 by accident. They forgot to times it by 2. Okay, we still got a level 3 on that question, but that was kind of the trick in the question was forgetting to double that there and back. Okay. Next question. Okay, good. Electricity costs 15 cents for 2 kilowatt hours. 1 month, a family of 4 used 950 kilowatts of electricity. What was the cost of the electricity? So this one we're just comparing 2 things. Cents or the cost and kilowatt hours, so it should be a straightforward one. See if you can set up your proportion. Okay, so I'm seeing cents and kWh. And then 15.6 over 2. And then the 950 is kilowatt hours, so it goes in the bottom, which makes X the cost on top. Okay? So that's your first probably 2 marks, is to get the proportion right. And then solving it is 2 marks. First to do the cross products and then your algebra stuff. And then 1 mark for your sentences. Only 1 proportion involved. So 2x equals algebraic step would be to divide by 2. 7,410 cents. But you wouldn't say that, would you? How do you figure out how many dollars that is? You shouldn't have to do a proportion. You know that there's 100 cents, right, in every dollar, so you just divide this by 100. Or move the decimal over 2 places. Okay, one of those things from elementary school. So divide by 100, because there's 100 cents in a dollar, and that'll give you $74.10. Or you think move the decimal 2 places to the left, one or the other. So therefore, it costs $74.10. Okay, so just so if it's over $1, it's in cents, change it to dollars. Okay? You ended up getting 85 cents, you could leave it as 85 cents. If it's over $1, change it to dollars and cents. right, if you look at the next one, we're on one of those ones where we're comparing three things again. Okay, so it's going to take us two proportions to compare three things. A gardener takes half an hour to mow a lawn that measures 25 meters by 15 meters. He charges $25 per hour. So we're comparing 25 meters by 15 meters is an area, okay? So we're comparing area, hours, and money, okay? So you're gonna leave the money out for now. And we're gonna compare hours and area. So you can only compare two things at a time using proportion. So you leave one dimension left usually till the end, so dimension money last. And this is going to be our first proportion. So I'm going to label it with the number 1 here. So it connects together a half an hour with a lawn that is 25 by 15. So for the hours, I could put 0.5 because that's half an hour. So that's why I put 0.5 there. If a lawn measures 25 by 15, how do I get its area? Because that's what they're mowing. They're mowing the area of the lawn. Okay? Anyone remember how to get the area of a rectangle? Length times width? Yep, perfect. So you can just do it on your calculator, but I'm going to show it 25 times 15. That gives me 375 meters squared. So that means it takes a half hour to mow a lawn that has an area of 375 square meters. Okay? At this rate, how much will it cost when he cuts a lawn that measures 49 by 30? So first, before we can find out how much it costs, we need to find out how many hours it takes him. Okay, so that's going to be our X. This is a bigger lawn. So it's going to have a bigger area, and you get the area by multiplying. By means multiply. All right, so you do 49 times 30, and that gives you the area of the bigger lawn. 1,470 square meters. So it's more than twice as big. So we're expecting it's going to take him more than an hour even, okay? So we have 0.5 because it was half an hour, 375 because that's the area of the lawn that took him half an hour. Now we want to know how long it takes him to cut a lawn with an area of 1,470. So we do our cross products. And get 375x equals 735. And then we're going to divide by 375. 1.96 hours. So it's almost 2 hours. But so what does this mean again? You might want to just write out 1.96 hours. That's how long it takes. Okay. So then I want to do my second part of my work. And that's where I'm going to compare dollars. So to read the question, dollars per hour. I want to know how much does he charge, or how much will he get paid if he mows this bigger lawn? Based on, he makes $25. He makes $25 per hour, means per 1 hour. Okay? Makes $25 in 1 hour. We know he's working for 1.96 hours. So we want to know how much money he'll make. So your dollars are both on the top, $25, and we want to know how many dollars, and our hours are on the bottom. Cross. 1 times x is just x, so that's really easy. And you end up getting 49 exactly. At this rate, how much will the gardener earn? Therefore, he will earn $49. You look back again, X represents dollars. All right, we have 2 more to go. Similar types, okay, and these are EQAO. The first one's an EQAO question, the second one I just made up, but it's similar. So Marcus and Minnie are paid an hourly wage. 1 week, Marcus works 30 hours and earns $83.82.50. The same week, Minnie works 38 hours and earns $497.80. If they both were to work a 40-hour work week, who would earn more money and by how much? So who earns more money and by how much? So this is, they've got different rates. Or we assume so because they say someone's going to earn more. Okay, so they have to have different rates. So we're going to divide this question into Marcus on one side and Minnie on the other. We're going to make the same comparison for them. Hours and money. When I'm working with money, I always like to have money on top. So I'm going to do dollars over hours for Marcus. So for Marcus, if I read the question here, it says he makes $382.50 for 30 hours of work. And I'm leaving Minnie alone right now. We want to know if they both work a 40-hour work week. So if Marcus works 40 hours, how much does he make? And then we're going to do the exact same thing for Minnie, and we'll figure out who makes more, and we'll be able to figure out how much more that person makes. So we've got 30x equals 15,300 divide by 30. that Marcus makes $510 for a 40-hour work. Okay? Now you want to do the same thing for Minnie and see how much Minnie makes for a 40 hour. And then we'll know who makes more. And then we can subtract to see how much more. So Minnie, we're still comparing dollars and hours. But they gave us different information on Minnie. So for Minnie, we had to read from the question that she earned $497.80 for working 38 hours. And we want to know how much she earns for 40. We both worked a 40-hour work. So 38 X equals 19,912. $524. Okay, who earns more and by how much? So we have to answer both of those. So therefore, Minnie earns more, because we can see them. There's Marcus and there's Minnie. So therefore, Minnie earns more by, and the way you would do that is 524 subtract 510, which would be $14 by $14. Okay, so we had to do two proportions because they had different rates. But we were both comparing them to 40 because we wanted to see who made more for a 40-hour work week. Okay? And then the biggest thing people forgot on EQAO was actually finding that $14. They would just stop and say Minnie earns more, and they just forgot that last little step of how much more. Okay? So read the question carefully. Always make sure you answer what they ask. All right, and then I made up one similar, so I'll give you guys time to try that one. Okay, so tons of people have the two sides. This is Martin, this is Northwood. And everybody was comparing meters and minutes. Whether minutes was on top or meters was on top doesn't matter, as long as your numbers line up properly. So Mrs. Martin's is actually probably the harder one because you have to realize that that represents 45 meters in 1 minute. And it says per minute, that's for 1 minute. Okay? Probably the hardest part of the question. And then they each walk 2,000 meters. And then we're going to figure out how long it takes Mrs. Martin. So we'll put an X there for minutes. She's going to be mad if I win. I didn't work it out, so let's hope she wins. So we get 45x equals 2,000. So take her 44.4, approximately, because the 4s go on forever, 44.4 minutes. So now we're going to see how long it takes me. So it says that I walk 250 meters in 4 minutes. How long is it going to take me to walk 2,000 meters? So that would be my proportion. So then we're going to cross. So 250x equals 8,000 divided by 250. Uh-oh, I won. I'm gonna hear about this at lunch. Okay. Oops. Okay, so it only took me 32 minutes, and it took Miss Martin 44.4 minutes. So we want to subtract them again. So who's faster? Therefore, Mrs. Northwood is faster by 12.4 minutes. She probably had like big weight she was carrying. Okay, so those last two examples were, there's different rates, but you're looking for who's faster, who makes more money overall, something like that. But the two different people, two different rates about something. Okay? And then the other ones were ones where there was 3 things you were comparing, and you had to do one proportion first and one second. Those are the 2 hardest ones, and the rest of them are pretty straightforward. So we're going to give practice 18 out. There's 11 questions on it, tutors, and we've got 25 minutes. You might have to pick 5 right now that you feel are important. So look and figure out the 5 that you think are good. Do that for tomorrow. Make sure you target a straightforward one where you're comparing 2 different rates, one where there's 3 different things you're comparing. Yep. Sorry, can you get closer? We'll do our best. If he's here tomorrow, then we have all tomorrow, and we're still doing the questions, even though it's for that. And then we have all the next morning. Okay? Because it's not in 9 altogether. So you're supposed to have learned that in grade 7 and 8.
This stuff reminds me of the codes and signs stuff from grade 11. Was it like that?
Okay, but it's in the grade 7 and 8 curriculum, so it's not in the grade 9 curriculum. You guys did parallel perpendicular lines.
Why you guys have that?
I'm using the lines standard for. I know, but that's what was inclusive.
What's the stuff that was during grade 11? And we set it up, I guess what was that code?
So Katoa and Sanma.
Yeah, that's one. I remember that's what it was. I don't know.
It's unfair. actually one of those great like.
Yeah, oh, yeah.
All I remember doing is the carry on base behind the parking lot and then we have to go on flex ones where he's like, that's the shape and how.
There'll be the odd question, I guess, on a non-academic, and some kids get it, some kids don't, but we just don't have time to do a unit, because I think we would be able to do that really hard in the geometry.
I remember
I didn't learn top off fine.
In elementary school.
Yeah.
I don't remember it, I did.
I just remember copying the
Here's
girls'
the gift, that you've
chalkboard.
learned something new,
Yeah.
and you
I just remember from grade 9, Mr. Ramirez filling the entire chalkboard with writing, and then us having to copy it. And I didn't know that. Such a news.
Okay, so this is
It's